The second type of multiple event is OR. In number 6, it states, given two standard dice, what is the probability of rolling a sum of 10 or a sum of 6? Starting off with a sum of 10. For a sum of 10, I can get a 4 on the first die and a 6 on the second die, or I can get a 6 on the first die and a 4 on the second die, or I can get a 5 and a 5. So these are the three different ways that I can get a sum of 10. Again, you can also look at the entire sample space of rolling 2 die, and you would find that right here. A 4 and a 6 and a 4, as well as a 5 and a 5. And these would be the three different ways that you can end up with a sum of 10. How many different ways can we get a sum of 6? I can get a 1 on the first die, a 5 on the second die, or a 5 and a 1, or a 3 and a 3, a 4 and a 2, or a 2 and a 4. So there are 1, 2, 3, 4, 5 different ways I can get a sum of 6. Going back to my sample space of rolling 2 die, I see that here as well. A 5 and a 1, a 4 and a 2, 3, 3, 2, 4, or 1, 5. So for sum of 10, we said that it was 3 out of the total 36 in my sample space. Sum of 6 would be 5 out of 36. The word or, I want either a sum of 6 or a sum of 10, would be the sum of these two probabilities. And that would equal 8 out of 36 is the probability that either of those happen, which reduces to 2/9. Point 2 repeating. For question 7, given the same 2 dice, what is the probability of rolling a sum of 7 or an odd numbered sum? I'm going to do the same thing that I did previously by listing out all the different possibilities. For a sum of 7, it could be a 1, 6, 6, 1, 4, 3, 3, 4, 2, 5, 5, 2. There are 1, 2, 3, 4, 5, 6 out of the total 36 in my sample space where I can get a sum of 7. For an odd numbered sum, this might take a little bit longer. A 1, 2, 2, 1, 2, 3, 3, 2. So an odd numbered sum can't equal 1 because 1 plus 1, the smallest, would be a sum of 2. It could be 3, 5, 7, 9, 11. It can't be 13 either because the largest possible sum would be 12, 6 plus 6. So I have a sum of 3, sum of 5, a couple more, 1, 4, 4, 1, sum of 7, 2, 5, 5, 2, 1, 6, 6, 1, 4, 3, 3, 4, sum of 9, 4, 5, 5, 4, 6, 3, 3, 6, and sum of 11, 5, 6, and lastly, 6, 5. So I have 18 out of 36 is an odd numbered sum. However, I can't just add these two probabilities together. Odd numbered sums also include sum of 7. So what I've done is repeated some of the outcomes. The 2, 5, 5, 2, 1, 6, 6, 1, 4, 3, and 3, 4 were already listed in the previous event. Therefore, what I have to do is, for this example, subtract out the overlap that occurred. Subtract out the 6 that I counted twice in my probability. So if I subtract 6 out of 36, I get rid of any repetition between the two events, and my final answer is 18 out of 36, which is just 1/2. So what makes the calculation of events 6 and 7 different? Well, number 6, the two events were completely exclusive of one another. There was no overlap between the two events. Whereas in number 7, there were repeated outcomes within the two events. The first example are called mutually exclusive events. Whereas the second example for number 7 are not mutually exclusive events. For mutually exclusive events, the probability of A or B happening would be the sum of both probabilities, the probability of A plus the probability of B occurring. For not mutually exclusive events, the probability of A or B occurring would be the probability of A plus the probability of B. Remember to subtract the overlap that happens between the two, the probability of both A and B occurring. For not mutually exclusive events, which sometimes could also be inclusive events, we want to remember to subtract the probability of both occurring. For not mutually exclusive events, which sometimes can also be called inclusive events but not always, we always want to remember to subtract the probability of both occurring. Please read 8 and 9 and attempt both problems on your own. You can pause the video at this time. Moving on to question number 10. There is a school leadership team that's made up of 10 seniors, 8 juniors, 5 sophomores, and 3 freshmen. They need to form a special 4-person committee for an upcoming event. If they drew random names out of a hat, A, what are the chances that the committee will be all seniors or all upperclassmen? So, or means that we are adding the two probabilities together. And we also have to determine, are these exclusive or are they not exclusive? So the probability of being all seniors plus the probability of being all upperclassmen. Think about the two events that you currently have. Because we know that seniors also are included in upperclassmen, we would subtract out the probability of the seniors. The probability of getting all seniors, it doesn't matter necessarily the order in which we're choosing this 4-person committee, so I know that this is an example of a combination. If the probability of an event occurring is always equal to the number of ways the event can occur, divided by the number in my total sample, the total number in my sample, how many different ways am I able to select a 4-person committee in general of all the total students that I have? I have 10 plus 8 plus 5 plus 3 students, so I have a total of 26 students. I want to know what is the total number of ways I can select 4 people out of the total 26. That would be the combination of 26, 4. In my numerator, I also want to know what is the number of ways my event can occur. My event is that I pick all seniors for this 4-person committee. So the combination of the 10 seniors that I have, how many different ways can I select 4 of them, plus the probability of picking all upperclassmen. Again, the denominator is the same. The number of total in my sample would be the combination of 26, 4. That's how many different ways I can select a 4-person committee. In my numerator, upperclassmen would consist of juniors and seniors. So I have 10 seniors plus 8 juniors would be the combination of the 18 upperclassmen. How many different ways can I select 4 of them? And then, of course, I would subtract out the probability of seniors again. And essentially, these two would cancel out, and I would end up left with just the probability of upperclassmen, which would be 306 out of 1,495. Of course, you could also approximate it if you want to. That's about 0.2047. I'd like you to read letter B and attempt that one on your own, and we will be going over that together in conference next class. Letter C, what is the probability that there will be 3 freshmen and 1 senior? So this is the probability of 3 freshmen and 1 senior. So I know I'm multiplying these two together, the probability of 3 freshmen times the probability of 1 senior. For these two events, you want to determine, are they independent or dependent of one another? You can't have a freshman who is also a senior, so therefore these two are independent events. You would just multiply the probability of 3 freshmen times the probability of 1 senior. For the denominator, the total number in my sample, how many different ways can I select a 4-person committee would still be the combination of 26, 4. Of the 26 students, how many different ways can I select 4 of them? In my numerator would just be the probability of 3 freshmen. So how many different ways can I select 3 freshmen? Of the 3 freshmen that I have, I would need to, of course, select all 3 of them. So it would just be, there's one way of that happening. The probability of selecting 1 senior, that would be, of the 10 seniors that I have, how many different ways can I select 1 of them? This is equivalent to 10 out of 14,950, which reduces to 1 out of 1,495. And lastly, letter D, if you can read that on your own and be prepared to share your answer in conference next class. What is the probability that they will be all juniors? The question hasn't changed. We still have a 4-person committee. The probability of an event occurring is still equal to the number of ways the event can occur divided by the total number in my sample space. The total number in my sample space would be, of the 26 students that I have, how many different ways can I select 4 of them? Still a combination, because the order in which I choose my students do not matter. In my numerator, the number of ways the event can occur, the event is specifically that they will be all juniors. So how many different ways can I select 4 juniors out of the total 8 juniors that there are? That would be the combination of 8, 4. When you find your final answer, the reduced fraction is equal to 7 divided by 1,495. And lastly, letter F, what is the probability that there will only be 2 juniors or only 2 seniors? Probability of 2 juniors or 2 seniors. This would be equal to the probability of selecting 2 juniors plus the probability of selecting 2 seniors. And now we would have to determine, is it possible that these are not mutually exclusive of one another? When I'm working on this problem, what I want to do is work on each portion one at a time. I'm first going to start with finding the probability of selecting 2 juniors. I have to actually pick a 4-person committee though, so I would have to start with the combination of the 26 total students that I have. How many different ways can I select 4 of them? That has to be the total number in my sample space still. In my numerator, the number of ways the event can occur. The event can occur with 2 juniors and 2 of another age group. So the numerator would be the 2 juniors. How many different ways can I select 2 juniors from the total 8 that I have? And the remaining 2 people would be of a different age group. So if I take out all 8 of the juniors, then I have 18 students remaining. And of the 18, I still have to select 2 of them so that I can make up a total of 4 people in that 4-person committee. So that is the probability of me selecting 2 juniors. Or means that I'm adding, so plus the probability of selecting 2 seniors. Again, it's still the combination of 26, 4 for my denominator. I still need a 4-person committee. And for the 2 seniors, I know that I have a total of 10 seniors. So how many different ways can I select 2 seniors out of the total 10 that I have? However, since I'm making up a 4-person committee, I have to also have 2 more students of another age group. If I have 26 students total and I'm excluding the 10 seniors, I would have 16 students remaining. So of the 16, I want to select just any 2 of them. And that would be the probability of me selecting 2 seniors. However, I do have overlap in the 2 events. There are groups of 2 juniors and 2 seniors in the events I have circled. I have to subtract out the probability of 2 juniors and 2 seniors because I counted that group twice. In this grouping here, the first one, I could have had 2 juniors and 2 seniors. I also could have had 2 juniors and 2 seniors from the second probability. So because I counted that group twice, I have to subtract out that intersection. So subtract, the denominator is still the combination of 26, 4, and the numerator would be the total number of ways I can select of the 8 juniors, 2 of them, and of my 10 seniors, 2 of them. For my first probability, it would have been 28 times 153 divided by the total 14,950 plus the probability of the 2 seniors was 45 times 120 divided by 14,950 minus 28 times 45 divided by 14,950. And my final answer would be 8,424 divided by 14,950, which I believe would reduce to 4,212 divided by 7,475. As always, if you leave your final answer as a decimal, it would be approximately 0.5635, which is more than 50% likelihood that you'll end up having 2 juniors or 2 seniors.